Hi, Robert.
Hello, how are you?
I'm good. How are you?
Good. I'm glad
you.
we connected. The link in my calendar was the wrong link, apparently.
Yes, I'm not sure what happened. Maybe it's because I changed my email, because with the other account I cannot record the video meeting.
Yeah, probably it.
Yeah,
Software.
some bugs, right? Okay, so thank you so much for accepting my invitation for this
Sure, my
chat.
pleasure.
So I'd like to start with a short testimony. 2 years ago, the same way that there are ivory tower software architects that don't touch the code, there are also ivory tower professors that don't touch much of the code. And so 2 years ago, I realized that I should, focus more on the craft of software development, and I started reading your books. I started studying and practicing, and so I'm really happy with this new phase. And you were really key in this, because I study your books and I also watched your talks, and they were really inspiring. So I'm trying to keep my hands on the keyboard, as you say, more often. So thank you so much. So I'm really skipping some formal presentations, because you're really popular down here in Brazil. I don't know if you know this. Every time I go into LinkedIn, there's some picture of your book and someone who's starting to study clean code, clean architecture, and all the books that you wrote. And so, if you don't mind, I'm skipping all this formal introduction, because you're really popular around here.
Yes. No problem.
And I'd like to start by asking you how you came up with the ideas of clean architecture. Was it something that evolved gradually in your head, or was it more like a sudden discovery? Because in the last chapter of Clean Architecture, you tell about your career, and it feels like you really felt the pain of badly designed software, and it seems like you derived the principles from real life, not from theoretical musings. So
that's certainly correct. And the last chapter of that book is the story about how these ideas very slowly and gradually leaked into my mind. It is the story of an awful lot of mistakes. And the purpose of the book is to try and help people not make some of the mistakes that I had to make along the way. We started, I started in this industry in the late 1960s. And at that time, people had been writing code for less than 25 years. Mm-hmm. And the code they were writing was on extremely weak machines by today's standards. Mm-hmm. So, my career followed the exponential growth of the hardware and the intense growth of software throughout the world. And because of that, I was fortunately or unfortunately exposed to an awful lot of architectural failures. And bit by bit, piece together some rules that I hope people find helpful.
Right. Yeah, great. And I'm sure you're familiar with Fred Book's No Silver Bullet.
Sure.
And I was wondering, do you think the clean architecture principles, they tackle essential software development principles, connecting with the accidents versus essential problems? Do you think that clean architecture attacks essential problems in software development?
Probably. Certainly that's true now. The way that we write software is with source files. We write source files and we compile those source files, or we run them through some kind of processor, and we link those source files to each other with using statements or import statements or some kind of source code dependency. And as long as that is true, then these architectural principles will remain extremely relevant. Mm-hmm. There is a a possibility that we will change the nature of what software is. We will change the nature of source code. And if that happens, and if it happens in a way that makes the source files no longer relevant, then there's a chance that these rules will have to be augmented. There'll have to be some tuning or changing of them. Because right now, everything that I write about, when it comes to architecture, is about the way we organize these source files and separate these source files and isolate these source files from one another. I do not know of any such revolution coming. I don't know if there will be a fundamental change to the way we represent code. It may stay as textual source files for a very long time. And if it does, then these principles will remain very relevant.
Right. Yeah, it makes sense. So I really like there's a definition of the word style where it's just like the imposition of restrictions, and then you have to work with these restrictions. And I think it kind of match with the way you describe the paradigms, like the structure paradigms and the functional paradigm and the object-oriented paradigm, where you say that we took away some things from the way we develop software, and I think that's really amazing. And Krista Lopez, who is a great professor from the University of California in Irvine, she wrote a book called Exercises in Programming Style, and she talks about this definition of style, and I think it's really amazing. She also mentions a French poet who wrote a whole book without the letter E. So I think that matches the idea of paradigm as you described. And I was wondering if that can also be applied to the clean architecture, where you impose some kind of discipline in the way you structure your programs. Do you think that makes sense?
It does. I mean, one of the rules in clean architecture, the most fundamental rule in the book, is the dependency rule. And the dependency rule says that source code dependencies must go from low-level modules to high-level modules based on some definition of level. And that's a constraint. It's a restriction, right? Very similar to the kind of restriction that structured programming puts upon you with the direct transfer of control, or object-oriented programming puts on you with indirect transfer of control. In this case, it's a restriction on the direction of dependencies between modules. So that kind of definition of style, I think, works very well and is part of the clean architecture. There are probably quite a few little restrictions like that in the book, but the dependency rule is the biggest one.
Right. So some developers, because I talk a lot about clean architecture in my channel, and some developers say that sometimes trying to match your architecture to something like the clean architecture or the hexagonal architecture lead to something like over-engineering, because you have to have all those boundaries and everything. And they feel that a professor like me that does not have to develop real software can talk about clean architecture, but that's not for them because that's not the real world. And one of these developers even made the comment that these things only work on books, not in real life.
Yes.
What are your thoughts on this? Do you think that there's this relation, if you try to apply the clean architecture, if there can be some over-engineering? What do you think about this?
Oh, there's certainly plenty of opportunity for over-engineering. If I'm working on a small application that's less than 5,000 lines of code, I am not applying clean architecture rules with any kind of diligence. There's just no point in doing that. You don't need a well-structured architecture for a small application. If I'm solving one of the Euler problems, for example, just for fun, maybe I'll be writing 200 or 300 lines of code. I'm not going to be, worried about the dependency rule. I'm not going to be worried about those things in a
Right.
small application. Most college students spend most of their time on relatively small applications. And so the rules of architecture probably don't have any way to for them to identify with.
Mm-hmm.
When you get into the industry and you start dealing with applications that are hundreds of thousands of lines or millions of lines, then these ideas become critically important. And without them, it is very difficult to keep a large software system in any kind of control at all. They will just get out of control. They will,
Yeah.
you'll end up demanding to redesign them all.
Mm-hmm. Yeah, it makes sense. It makes sense because there's this. I think there's this culture, especially in the JavaScript community, of hacking things together to build applications. Do you think there's space for this for this kind of simpler applications? I even heard the term minimal viable architecture for
Yes,
this kind of applications. Do you think there's space for this for smaller and simpler applications, or most more sophisticated applications you have to apply something like a good architecture, layered architecture?
well, if you have a very large system and some part of that system is written in JavaScript or TypeScript or Clojure script or something like that sits out on the browser, it is very important to separate the stuff that belongs at the browser from the stuff that does not belong in the browser. You don't want business rules sneaking out into the JavaScript code. You also don't want formatting rules sneaking into the server-side code. You want to keep those things very separate. And so even though the JavaScript code is relatively small and by itself might not need an architecture, it has to fit into a system which does have an architecture, and the rules apply very, very strongly in those kinds of systems. If you're writing a little JavaScript toy, you don't need that kind of architecture. But if you're working in a large system and you feel isolated from everybody else because you're the front end guy and those are the back end guys, you're doing the entire team a disservice if you're not paying attention to the architecture of the system.
Right. Yeah, makes sense. Yeah. So this is more of a clarification question about the clean architecture. So you have the domain layer, and then the use case layer, and then the adapter layer, right? Where you have the MVC and the gateways to the database. And I was wondering, so imagine you have a use case that talks to a database. Like, for instance, it's going to talk to a user repository. And so the idea that, if I understood correctly, is you shouldn't talk to the database directly. You should have an interface. For instance, you have a user repository interface, right? But then it comes a time when you have to implement the actual database, right? The actual communication with the database. And this will probably be an adapter, right? For instance, if I have a user repository interface and I want to use MongoDB, I'll have a MongoDB user interface, right? Implementing that interface. So my question is, does that adapter, the MongoDB user implementation, does it belong to the adapter layer, or is it in the more external layer, because it's communicating with the database directly, right?
So yeah, that layer communicates with the database directly, and it communicates with the use cases. So it sits between those two. And the use cases are very high level. The database is very low level, and the adapter is somewhere in the middle.
Right.
Now, which layer does it belong in? In a moderately sized system, it would be safe to put that in the database layer. Just couple those two together and then forget about it.
Okay.
On the other hand, if you have a larger system and a system that you suspect will have different database implementations over the years,
Mm-hmm.
then you may want to take that adapter and put it in its own layer.
Right.
Because it is higher level than the database, and it is lower level than the use cases. The model that I draw in the book and in a number of my blog articles shows a fixed number of layers. And there's the use case layer and the adapter layer and the database and the IO layer and the entities layer. All of these layers show up in my diagrams. But that does not mean that the rules dictate that there are 4 layers.
Right.
In some applications, there might only be 2 layers because it's just not worth doing the separation. In other applications, you might have 6 or 7 layers. You may decide that there are higher level and lower level use cases, for example. You may decide that there are higher and lower level adapters.
Right.
So, and again, this takes a fair bit of experience and seasoning and kind of the ability to look into the future and say, if I don't do this today, I'm going to get burned.
Yeah.
Usually we warn against that kind of thing. Usually we say, well, you don't want to look too far into the future because you're probably wrong when you try to predict the future. But a seasoned architect will get this itching in the back of their head, right there, just itching, and you think, I think I better separate these two, just because I know something's going to happen. That's always risky, but I do it. I think a lot of other architects do it too.
Right. Yeah, it makes sense. Yeah, I was wondering about the validation of data when data comes into the application. I've seen people doing validation on the controller, for instance, and I've seen people doing validation in the domain layer with like value objects that have self-validation. What do you think is the best approach for validation? Where should it be implemented?
So you can divide validation into layers, and usually there are only 2 layers. There can be more than 2, but usually it's 2. And I like to name them the syntax layer and the semantic layer.
Right.
So out towards the inputs and outputs, out at the JavaScript, if you wish, you probably want to do some syntactical validation of the data coming in. So let's say you've got a date field. You'd like to make sure that the date is a valid date. And you'd want to do that out as close to the inputs as possible. But now let's say that the business rule that we're dealing with demands a date in the future. Maybe it's the date that some loan is going to be paid off. We don't want that to be in the past. That's a semantic validation, and that belongs close to the business rule. Okay. So we would separate these two and drive one to the drive one to the inputs. And that would be the syntactic validation. And then drive the other towards the business rules. I would put that one in the use case itself, not in the controller. The controller, it's not the controller's business. Once the syntax analysis has been done out towards the inputs, then the semantic validation should be done at the use case level.
Oh, okay. So probably it wouldn't be very correct to do validation in the domain layer.
Usually it's the use cases that are putting those constraints in.
Right.
There could be some invariance at the business rule level, at the domain level. And in that case, you'd probably put some validation there as well. That would be very high level stuff, very, very strongly semantic as opposed to syntactic. So let's see if I can come up with an example of that. There could be a business rule for a loan. I'm making this up as I go along. There could be a business rule for a loan that demands that all loans must be repaid within 20 years. the use case doesn't need to know that.
Okay.
The use case should probably make sure that the data is in the future and it's, you know, it's a reasonable kind of semantic analysis. But then there's this business rule that says, no, they must be paid off by before 30 years or before 20 years. And that kind of validation would occur in the business object itself.
Okay. Mm-hmm.
Right. Mm-hmm. So that's what I mean by this idea that there are levels of validation that roughly follow the levels of the code that we're separating the architecture into. Some validation is low level and it goes as far out towards the inputs as possible. And some validation is very, very high level and it goes as close to the business rules as possible.
Right. So things like checking if an email address is correct should be more close to the UI, do you think?
Yeah, if it's syntactically correct, it's got the @ sign in it. It's got a 2-component domain name, at least a 2-component domain name, and the right alphanumeric characters in the user's name. That would you'd put all out at the input level, way out in the JavaScript or at the lowest level you can. But then to identify that it is a username in the contact list, then you would do that at a much higher level. Right.
Yeah. So the idea is that you make sure that the data that is coming to the entities is already validated, right? So when you create a user, for instance, with an email, you know that this email that is coming from the UI is at least syntactically right. Is that correct?
Yes.
Okay. Yeah.
And at the use case level, once you get into the use case, it'll be semantically correct.
Right.
And then the business object doesn't have to worry about anything except the very highest level constraints.
Okay. Yeah, it makes sense. Yeah. So another question about the use case layer. So you say that the use case orchestrates the dance of the entities, which I like very much that analogy. And so my question is, in a given context where you are getting data from the database and you are creating your entities. So the idea is that you're only creating the part of the model that you're gonna use right now, right? Necessary for the use case that you have in hand. You don't have to create all the model of the system, right? When you are going to run a use case, right? So it's just a question of when you do the dance of the objects, you only have to pull in the data from the database required for those objects that you're gonna work with, right?
Yes, that's correct. Yeah. So every use case has a subset of the business objects that they're going to play with. And so the use case, if the use case is smart, then the use case will go to the database and fetch just enough data to allow the model of the domain model that's relevant to that use case to be in memory. You can do it that way. You can make it so that the use case knows. That's a little bit of coupling that feels uncomfortable, because now the use case knows about the interconnections of the business objects. And most of the time I would tolerate that. Every once in a while, though, you might decide that it's better to have the use cases not know this. The use cases would only know the primary business object that they need to deal with. And then the business objects would fire back requests to the use case saying, hey, I need this other thing. Okay. And you can do that very, very indirectly, right? You could have functional calls where the business objects are actually talking to proxies. And those proxies then tell the use case, oh, you got to get my real guy. And the use case would then go get the real one from the database and populate it and then forward the call on. To understand what I just said, you'd want to study the proxy design pattern very, very carefully so that you know how to do this well. Usually I would not do that because it's an awful lot of indirection. Okay. But sometimes you want the isolation between the use cases and the domain objects to be very strong. And in that case, that kind of a system would work out well.
Okay. makes sense. Because, I've been practicing these ideas. I want to really put them into practice because most of my students are going to be software developers. And if I don't know how to use these things, how am I going to teach them, right? So that's why I asked these very specific questions to clarify the clean architecture. And I think these are questions that come from reading your book and trying to understand better these ideas. And moving along to a higher level idea about design patterns and solid, there's been this talk about these things being outdated, right? That they're not valid anymore. And I read an essay by Paul Graham. I don't know if you're familiar with him. He's the founder of Y Combinator, and it's kind of an old essay from 2002, and it's really interesting. It's called The Revenge of the Nerds, and it's really nice because so if I understood correctly, his idea is that Lisp is like the pinnacle of programming languages, and all the languages are kind of converging to Lisp. So, and at the end of the essay, he mentions that he thinks that design patterns are kind of a sign of a restriction of your language. That is something that your language are not allowing, and then you have to use patterns to, work around those limitations. And also he mentions a work by Peter Norvig, where he shows that I think most of the design patterns do not make sense when you think about functional and dynamic programming and all those things. What are your thoughts about this? Do you think these things are outdated with functional programming and dynamic languages?
This is a very big topic. So let's begin with the first part of the question. Are these ideas outdated? And the answer to that is no, they're not outdated. Very little in software gets outdated. Some languages are now obsolete. COBOL, I don't want to program in COBOL anymore. I'm not real enthusiastic about programming in Fortran anymore. I actually don't think I'd want to do much coding in C anymore. On the other hand, most of the concepts we have learned over the last 70 years remain as true today as they were back then. Structured programming, object-oriented programming, functional programming, architecture, all of these things remain very relevant. What's happened is that we've just experienced over the last 50 years this unbelievable exponential growth. And people of my age grew up during a time when computer power was doubling every 18 months. There was a time when you could not keep a computer. You had to trade it in for a new one every year. The software would not run on the old machines because they were so vastly underpowered just a year or two later. So that's the kind of environment we grew up in. And that created a kind of emotional momentum. We expect things to change. We expect them to get better and better and better at this exponential rate. But they're not anymore. That stopped in 2003. And for the last almost 20 years now, we have been on a technological plateau. And nobody likes this. Everybody wants this to continue. We want the growth to continue. The idea that things get outdated is part of that emotional momentum. Oh, that was what we did 20 years ago. Everything is different now. But it's not. It's not different now. It's the same now as it was just about 20 years ago. The laptop that I'm using now, I think is 2 years old. The one before that, I think I had for 6 years. The one before that, I think I had for 6 years too. And we just don't turn them over the way we used to. And that will continue into the future. So the idea of things getting outdated is an illusion that came from this wild exponential growth in the hardware. Now, Paul Graham, he mentioned design patterns. Are design patterns a symptom of weakness in the language? In the languages that we use? Are design patterns a symptom of the weaknesses of Java and C# and C++ and Ruby and so on? No. No, that is an incorrect statement. There are aspects of the design patterns, of certain design patterns, that are influenced by languages. Mm-hmm. So a simple example of that. There are two basic families of languages. There are the dynamically typed languages and the statically typed languages. In statically typed languages like Java and C# and C++, the only way you can get dynamic polymorphism is to use inheritance. So inheritance becomes really important in those languages. In dynamically typed languages like Ruby and Python and Clojure and so on, inheritance is almost a non-entity. Dynamic polymorphism is achieved through a different mechanism. When you look at the design patterns assumed, for the most part, that you were dealing with a statically typed language. And so you see a lot of inheritance relationships in those design patterns. But the patterns work just as well in a dynamically typed language without inheritance. You do have to jitter around a little bit and change a few rules, but the same ideas still apply. Is there a strategy pattern in a functional language? Of course there is. Is there a visitor pattern in a functional language? Yeah, they call it double dispatch, but yes, there is a visitor pattern in functional languages. Are there proxy patterns in these languages? Of course there are. You have to fiddle with it. The languages don't fit the same way, but the patterns are all still there. So I reject the idea that the design patterns are just patches on bad languages. Mm-hmm. Now, in the end, Paul Graham says all languages are converging towards Lisp. With this, I agree. I agree with that statement. I believe that all languages are converging towards Lisp, and in the end, we will all be Lisp programmers, no matter what else happens.
Okay. So you suggest everyone go and learn some functional programming languages like Clojure and Lisp.
Oh yes. Learn a Lisp. Learn and learn it well. Learn a Lisp and learn it well. You may not program in it for another 10 years, but the concepts will pay you back enormously.
Great. Yeah, it makes sense. So talking a little talking a little about TDD, because TDD is something I really love. I really love using TDD, and I think it's really something that more people should be doing. I'm sure you think that too. But there was a talk about TDD being dead a while ago, and I think that's kind of related to a style of TDD that I don't like very much, where you use too many mocks. And what are your thoughts on this? Do you think this TDD style that use many mocks kind of got in the way of people learning TDD and doing TDD?
No, I don't think that. There's two fundamental schools of thought. And the one school of thought is that, yes, you use mocks everywhere. Mm-hmm. And the other school of thought is, no, you use return values as much as possible. And you use mocks only where absolutely necessary. I'm of the second school. I tend not to use very many mocks. I like to use mocks only across certain areas. And I'll tell you what those areas are in just a moment. The first school of thought, which is sometimes called the London School of Thought, puts an awful lot of mocks. I got to say this correctly. It looks like they're putting an awful lot of mocks in. In the end, they actually don't. It just looks that way. And they use a lot of mocking libraries and mocking tools. And so you kind of get the feeling that they're over mocking things because they use these tools a lot. But in the end, when you look at the end result between the two schools of thought turns out to be very similar. Sandra Mancuso and I did a study on this a couple of years back. It's like 14 hours.
Uh-huh.
He wrote an application using the London School of Thought. I wrote the same application using the Chicago School of Thought, which is the one that I like. And the way we approached the problems were very different. And the end result turned out to be really comparable. Not exactly the same, but comparable. Now, what do I think is best? I avoid using mocks unless I'm crossing an architectural boundary. If I'm crossing an architectural boundary, then I definitely use mocks across that boundary. Now, I tend to have a lot of architectural boundaries. I like boundaries. I think they're useful. So I will draw boundaries where other people might not, and then I will put mocks across those boundaries. And the London School puts the mocks in, and then the boundaries kind of appear. So it's very interesting difference of the way the two ideas work, but they tend to converge on the same result. The other thing that I do that the Londoners don't do is that I write my own mocks. I don't use tools. I don't use mocking frameworks. I find it's easy to just write my own as opposed to depending on a tool to try and construct one at runtime. So for the most part, the mocks that I write are written in code that I write, that I put in certain directories and libraries so that I can keep control of them.
Okay, great. So do you think that the London School leads to more coupling between the test and the production code when you use more mocks? Or is this something that is not related to London School, but the actual use of it? I mean, you can do London, but not be coupled with the production. What do you think about that?
Mocks couple to implementation. That's the weakness of a mock. Mocks couple you to implementations. It's not London School or Chicago School because they converge to the same result. But the weakness of mocks, and the reason that the London School in the end does not overuse them, is because mocks couple to implementation. So we try to avoid using mocks when the coupling to implementation would hurt us. Now, the problem with not using mocks is that you must, if you're not going to use a mock, you cannot spy on the implementation, and therefore you have to trust the return values. But you don't know if the return values are going to be right for every combination of input. If you were to rely only on return values, you'd have to supply every possible combination of input, and you can't. And so if you're following the Chicago School, you kind of cross your fingers a lot and say, well, gee, I hope this works. I'm getting the right return values most of the time or all the time, but I can't use every possible input. So I have to trust that the values coming back will be correct with other inputs. And that's an uncertainty. There's an uncertainty with not using mocks. You can get that certainty by using mocks. You can spy on the internal implementation, and that will give you all the certainty you want. But now your tests are fragile. Now your code is fragile because you've coupled it to the internal implementation. So there's this trade-off, and the trade-off is, how certain do you want to be? If you can tolerate a little uncertainty, then you go away from mocks. If you must be absolutely certain, then you move towards mocks. And to the extent you demand certainty, you will have fragility. And to the extent that you can tolerate uncertainty, you will have flexibility. We call this the TDD uncertainty principle.
Great. Yeah, that makes sense. It's a trade-off, right? In the end. So
it's a trade-off, right? Momentum versus position. You can't have both of them simultaneously.
Yeah. So what do you think is the percentage of developers that use TDD as their default programming methodology? Because I feel that few people, like 1-5% of developers, use TDD. What do you think? What's your feeling?
Well, it depends on their level of experience. But if you were to look at programmers that have 10 years experience, probably a quarter And
Okay.
I'm pulling that number out of thin air, just
Mhm.
from my own experience with talking to these people and so on. I don't have any real statistics, but I would say it's roughly a quarter of everybody who is who have 10 years experience are doing test-driven development.
Okay.
Less experience usually means less test-driven development,
Mhm.
and more experience. I think there's a peak. I don't know where that peak is. And as you get towards 20 and 30 years experience, it might start to fall off again, because those are the guys that are too old to try something new.
Okay. That makes sense. And do you think that it will ever become more popular among programmers?
Yes.
Okay.
Oh,
Yeah.
yes. Oh, yeah. It's a growing discipline. It will continue. It will invade the schools. This is what happened to accountants, right? The accountants had this problem. The accountants needed to make their spreadsheets, back when they weren't done on computers, they had to make their accounts balance. They needed some way to make accounts balance. And eventually they invented double entry bookkeeping. They enter everything twice, right?
Mhm.
And they balance it all by doing a subtraction on the balance sheet that has to be a zero. Test-driven development is double entry bookkeeping. It's exactly the same rule. It's done for exactly the same reason. It gives you the same result, a reasonable expectation that the code is correct. Not perfect, but a reasonable expectation that you've done the due diligence to make sure the code is correct. It gives you all the same things. And in the end, it will be the discipline, I believe, that if we don't adopt on our own, will be forced on us by our users.
Okay.
Who will look at us, with their eyes crossed going, what, you mean you aren't writing tests? I've hired you and you're not writing tests? What kind of buffoons would I have hired and they're not writing tests? So in the end, we will feel the pressure to be doing this. Our civilization depends critically on software. This did not used to be the case. But nowadays, nothing happens in our society without software. And at some point, society itself is going to point their fingers in our eyes and saying, you better be writing tests, because we're not going to be using stuff that you produce without reasonable testing.
Yeah, it makes perfect sense.
That's my theory.
Yeah, I think it makes sense. Yeah, I see a lot of people trying TDD nowadays, and I've been advocating for it on my channel and posts and everything. But it comes, there's a question that I have, because there are a lot of startups that produce software that kind of work, right? If you think about Instagram and Facebook and all those, Twitter, and I don't feel that they use, best practices all the way. And what to make of it? Do you think that they should be doing better, that they, or is it something that they'll learn and they'll have to rewrite the whole thing and learn that the hard way? or what to make of it? Because people say, well, my software is working, why should I care about TDD and all these architectural ideas?
So Facebook's an interesting example. I do not know what practices they follow. I know Kent Beck was at Facebook for a good, Kent Beck was at Facebook for a good long time. I hope some of his ideas infiltrated the culture there at Facebook. But Facebook's an interesting example because Facebook was not first. There was MySpace first, right? Everybody thinks they have to be first, and that's not correct, right? A lot of times the first guys in do not last, right? And the ones that have the better user model, or they have the better sustainable system, are the ones that succeed. There is this idea, especially in software, that if you're in a startup, or if you're doing a project that is starting up within a company, then you have to break all the rules and make a huge mess just to get something out there fast. And the end result of that is that you will get something out there slow. because when you make a mess, you go slow. Every single time when you make a mess, you go slow. It doesn't feel slow because you're churning and you're bubbling and you're making a mess and you're applying an immense amount of effort, and it feels like you're going fast and you're going slow. And if you stop and you apply good disciplines and you move at a proper rate, then you will go fast as it is possible to go. You will go fast and you will go well, right? And you will get done long before the guys who are, trying everything they can and working furiously. You will outdo them over and over and over again. This is a fundamental rule of software that you only generally learn after your 10th or 15th year. And it would be a good idea if we could get this into the heads of college students so they understand the only way to go fast is to go well.
Yeah, makes sense. Yeah. Yeah, I want to talk a little bit about microservices, because it's another fad, right? And I was wondering...
Microservices!
Yeah, I was thinking about microservices, and I was thinking that the way that we break the systems into microservices, is it the same way that we break systems into components as we did when we worked with components? Okay.
Yes.
Yeah.
Yes. The only difference between a component and a microservice is that you're going to communicate through a socket. You're going to take all this interesting stuff that you could do in a call, and instead you're going to squeeze that down into some kind of string that you're going to squirt through a socket and then reconstruct it on the other side so that you can call the function that you wanted to call. Generally, there is a time and a place for a service. Right? There are times and places where services are useful. But services and components are roughly identical concepts, and there is no reason at all to separate a component through a service layer unless you need the scalability or the security. And generally, you don't even need those. Just sometimes. Sometimes you will need certain levels of scalability or certain levels of failover or certain levels of security. And in those cases, a service is a good architectural decision. Many of the books, many of the blogs, many of the videos out there talk about microservices as being good in and of themselves. And they're not. They're actually detrimental. They add milliseconds to a function call that could be done in nanoseconds. Right? It's far better to get the decoupling you want by componentizing rather than serviceizing.
Yeah. Makes sense. Yeah. So about languages, about functional programming and object-oriented programming, another polemic topic. Do you think can you do everything with functional programming, or should we mix? Or is this a question of style, of preference? What do you think about this functional programming versus object-oriented programming fight?
So yeah, I don't know why it's a fight, and I've heard that there is this fight, and there are people that say that object orientation is the opposite of functional programming, and the two cannot be used together, and that's completely nonsensical. We have learned over the last 60 years or so that we should not have unconstrained go-tos, that we should not have unconstrained pointers to functions, and we should not use a lot of assignment statements. Those are the kind of things that we've learned. Structured programming, object-oriented programming, and functional programming. And we can do all of them at the same time. You can have a program that is structured, object-oriented, and functional. And you should. Because all of those constraints that we've learned over the years are good constraints. So nowadays, I write in Clojure. It's a functional language, but I apply all these same object-oriented principles. I apply all the same structured principles. The programs I write have all of those rules in them, and it makes for very good programs. I still use polymorphic interfaces in my Clojure stuff to isolate components. I still componentize the same way I would. I apply all the solid principles. I apply the clean architecture principles. All of the things that we learned when we were doing structured programming and then object-oriented programming and now functional programs, they all still apply. There's this idea, right, that functional programming is new and therefore the old thing is wrong. And that's wrong. The old things are not wrong. The old things are not outdated. They're just older. And they're still valid. And we still want to follow them.
Yeah. Yeah, it makes sense. It makes sense. So about the developer, about developer formation, there's this talk about, college versus boot camps versus self-teaching. Do you have any suggestion on how someone that wants to be a professional developer should go about their education?
I think there are many paths that work. The boot camp path, I have seen it work. I've also seen it fail. What I have seen work best over the years is for someone to have a basic grounding in the concepts, which you could get at a 2-year college, an associate's level kind of degree, and then enter the industry as a novice or as an apprentice and work under people who have much more experience. And that works very, very well. That's not the path I took because there wasn't anybody with more experience back when I started programming. So I had to learn everything the hard way. Right? But nowadays, there are enough people who've been in the business for long enough that it's possible for the 10-year people to mentor the new people coming in. And there are several companies who have adopted that kind of style, that kind of training style. So they bring in someone from college and they assume that the person coming in from college doesn't know very much. And then they will attach them to several different mentors. And over another year or so, those mentors will teach them the things they really need to learn. Universities in this industry have remained behind the industry for the last 20 or 30 years. In most industries, the universities get ahead, and then they can teach and funnel students into the industry. In software, the opposite has happened. Right? The universities are still behind, they're lagging, and industry is leading the technology. And so when the students come out of university or out of a 2-year college or even out of a boot camp, where they really learn it is in that first year or two of working in industry. And hopefully that's under someone who can teach them and correct them and make sure they're not crashing airplanes.
Right. Yeah. Thank you. Yeah, makes sense. Yeah, I've been, going the other way because I've been in the university for 10 years, and I'm learning, from like industry practice to try to pass that on to develop it. I'm also trying to have a closer relation to companies, so I'm doing like training and consulting, so I can really get this experience from like the real world, so we don't stay too far away from real industry practice. And I think I don't criticize other professors that don't do that, but I think that's a good way to bridge the gap, between the lag that you commented about the university being kind of far away from industry, and so I've been doing that. Do you have any book recommendations for my audience? I know you recommend Annotated Turing and Ivar Jacobson and Fowler Campbell. What else? Any new books you've been studying and that you want to recommend?
Oh, when I recommend books, I recommend old books.
Those are the bad.
Yeah.
The bad
So here, let me get like that. There is so much good stuff written in the past, right? So this is the one I recommend right now most. If anybody asks me for a book recommendation, I say, you've got to get this book and read it. This is the Structure and Interpretation of Computer Programs. And the best part about this book is that it's free online. So you can find this book, the PDF of the book, they gave it away. You can also find all of the videos where the instructors teach the concepts of the book. You can actually put yourself through an MIT computer science course using this book and using those videos, and you will learn a tremendous amount. So if you ask me for one book recommendation, that's the recommendation I'd give you.
Great. Yeah, that's really good. And what languages and technologies have you playing with lately? I know you've been playing with Clojure, right? Are you developing like full systems using Clojure? Because I wonder how, because most books that deal with like domain and modeling are more directed to object-oriented programming, and I wonder how you would model a domain using only functional programming.
There isn't a lot of difference between if I were to write a system in Java or a system in Clojure. There isn't an awful lot of difference. Once you start following good design principles and good architectural principles, your programs tend to be more functional anyway. And then if you're using a functional language, it just kind of drives you even farther away from using too many assignment statements. Do I write large systems? Yes. Yeah. So, for example, the website where we sell our videos, cleancoders.com, that's entirely written in Clojure from the bottom up. Right. My own personal website, cleancoder.com, that's entirely written in Clojure. All these programs are 100% Clojure, 100% functional, and they're fun to work in. They're easy to maintain. They're lovely little bits of code, good systems of code. So yeah, I do all those things. I write systems in Clojure. They look about the same as they would in Java, except that the objects are immutable.
Okay.
They don't change until the end of a process, and then you flush them to the database, and then you bring them back in, and the next one. And while you are in process modifying them, while you are in process, you are not modifying any data structures. And then at the end, you flush them to the database.
Okay. Yeah. Awesome. Really cool. Yeah, I wanna learn Clojure or Elixir. I don't know if you call Elixir or Elixir. Do you know that other functional language?
Sure. Yeah, Elixir, which was it's kind of a combination of Erlang and Ruby.
Yeah. It was actually written by a Brazilian guy.
Oh, was it? Elixir was?
Yes, it was.
Yeah.
So
yeah, I've seen a fair bit of Elixir. It's a nice language. Erlang is a nice language. Now there is a Clojure that runs in the Erlang virtual machine, so that it's called Clojure. Okay.
Cool. Yeah. Okay. So thank you so much for your time. And do you have any final message that you want to give for my audience?
I think the most important thing for a software developer to understand is that nowadays you're on the plateau. And life on the plateau is different from life climbing the mountain. I climbed the mountain, right? I went through this crazy exponential growth. People who are coming into the industry today are going to have decades on the plateau. And that's an opportunity to develop the disciplines and the skills and the knowledge that you can't do when you're climbing the mountain. because everything is outpacing you on the mountain. So pay attention to the plateau, pay attention to your skills, learn as much as you possibly can, and don't expect massive changes over the next several decades.
Okay. That's cool. Thank you very much. Thank you.
Very welcome.
Thank you so much. Bye-bye.